Hello Year 12. Today we're going to start by looking at particles and antiparticles, and the first thing we're going to look at is a proton. And before we go any further, I want to introduce the idea of rest energy. So if we had a stationary proton of mass 1.67 times 10 to the negative 27, we could say that that had what's called rest energy, given the symbol E0. That can be calculated using E equals mc squared, using that mass I mentioned a few seconds ago. We're not going to do that today, that's something for another day, but we're going to use the idea of rest energy with a lot of our calculations. The rest energy of a proton can be given as 1.501 times 10 to the negative 10 joules. And the joules unit is going to be something that's familiar to you. However, we are going to be using a different unit today, which is called the mega electron volt. So 1 mega electron volt is equal to 1.6 times 10 to the negative 13 joules. And 1 mega electron volt is also equal to 1 million electron volts, which is defined as the amount of energy that an electron would gain if it were accelerated through a potential difference of 1 volt. If you want to change in between mega electron volts and joules, it's not too complicated. If we want to go from mega electron volts to joules, we just multiply by 1.6 times 10 to negative 13. If we want to go from joules to mega electron volts, we divide by 1.6 times 10 to the negative 13. So just remember that. So let's go back to our proton. It's got a rest energy of 1.501 times 10 to the negative 10 joules, and for every particle there is an antiparticle. So here we have an antiproton. It's going to have an identical mass to the proton, so it will have an identical rest energy. Now, I'm sure you've heard in sci-fi and Star Trek and Star Wars and things like that, if matter and antimatter collide, then you have a process called annihilation. So these will get completely destroyed and converted into energy. So if these guys come along together like that, all of their mass is converted into energy, and that energy takes the forms of 2 photons of extremely high frequency, extremely high energy. The larger the particle, the more rest mass it has, the more energy the photons are going to have. So these photons could have energy HF minimum, and we'll explain the minimum bit in a second. And this one is going to be identical, but it's going to be moving in the opposite direction. 2 are produced, so we conserve momentum. Even though photons have 0 mass, they have kind of a momentum equivalency. So if we didn't have 2, their momentum would not be conserved. So if we have a look at each of these particles, this has rest energy E0, this has rest energy E0. So the rest energy here, the combination of the 2 rest energies, is going to be converted into the energy of the photons. Kind of like that. So you've got your 2 rest energies and then the energy of the 2 photons. So if we simplify this, this gives us 2E0 equals 2HF min, and obviously we can get rid of the 2's. So the rest energy of a proton can be equal to the minimum frequency of our photon produced multiplied by Planck constant.